All right, if you take a few minutes and go through and complete problems 1 and 2, and then turn the video back on, from there we will continue our work in the problem 3, which we started on Tuesday. So you get problem 1, 2, and you're finished, turn the video back on. All right, so we are taking and changing this into a radian. So they all start off the same way. Angle over 360 times 2 pi. The counts I made was, starting right up front, if you get rid of that 2, by dividing both of these numbers by 2, then what you end up with is 20 pi over 180. Here you have 140 pi over 180. And lastly, you have about 240 pi over 180. And from here you simplify. So for the first one, we both end in a 0, so that means I can divide both by 10, which leaves me 2 over 18, and then they both are even numbers, so I divide both of them by 2. So what I'm left with is a 1 in the numerator and a 9 in the denominator. So this ends up being pi over 9, the final answer. Second one, I can divide both by 10. They both end in zeros. Both are even numbers, so I can divide both by 2. So there's a 7 here and a 9 here. So final answer is 7 pi over 9. The last one, again, they both end in 0, so I can divide both by 10. Again, they're both even. Also, I noticed that 2 plus 4 is 6, so that means this is divisible by 3. And 1 plus 8 equals 9. That number is also divisible by 3 as well as 9. So not only can I divide this by 2 because both numbers are even, but I also can divide both of them by 3 because when you add the digits together, if the sum is a multiple of 3, then the number itself is divisible by 3. So altogether, I'm going to divide by 6. So 2 times 3 is 6. 24 divided by 6 is 4. And 18 divided by 6 is 3. So the final answer is 4 pi over 3. To get the angle measurement, we take the radian and multiply it by 180 over pi. And we'll do that for all 3 of them. As a reminder, this x start off being 360 over 2 pi. 360 degrees is the angle measurement for a circle. 2 pi is the radian measurement for a circle. And then we divided both numbers by 2. And that's where the 180 divided by pi came from. All right, so here we get rid of pi. Pi divided by pi is 1. So we have 180 divided by 5. Since both numbers ended up either a 5 or a 0, that means this problem is divisible by 5. So 180 divided by 5 is 36 degrees. In problem B, the pi divided by pi is 1. I would probably do 180 divided by 9, which is 20. 18 divided by 9 is 2. So I'm left with is 4 times 20. So the final answer here is 80 degrees. And then the last one, I divide both by pi divided by pi. 180 divided by 12 actually, by 15 actually works. 180 divided by 15 is actually 12. So I'm multiplying 7 times 12. That's what's left. Final answer is 84 degrees. All right, so in your group, if you continue with this problem, you did 2 of these on Tuesday this week, so go ahead and finish them up. Again, if I rotate negative 45 degrees, which means if I have a unit circle and I go 45 degrees this way, then how many degrees do I need to go this way to get to the same angle? So that we came up with that would be 350 degrees. On the positive side, we go negative 45 for the clockwise rotation. Same thing with the second problem. If I am going this direction, negative 3 pi over 4, then how much do I need to go this direction for the same angle, to get the same angle, and it's going to be 5 pi over 4. So go ahead and work on this as a group. Turn the video back on when you're done with problem 3 and problem 4. Alright, so hopefully you get your answer. Before we've actually talked about problem 4 and 5 multiple times in the last couple of classes. So while we're here, you go ahead and answer 5, and then what would be the exact answer for problem 6 if I wanted to know the coordinate of point P? And again, what I'm looking for is the exact value. So in other words, I don't want you to give me an answer as a decimal number, that's an approximation. I'd like you to write it as an exact answer. So for example, if this was, 45 degrees, we could write the coordinate as square root of 2 over 2, and comma square root of 2 over 2 to look at our unit circle. Here, they want the exact answer in radians, not as like square root of 2 over 2, but something that will give me an actual radian measurement. So go ahead and work on 4, 5, and 6, as well as problem 7. Turn the video on when you're ready to continue the conversation. All right, so for problem number 4, we've been talking about the fact that to get the exact x value, this is a cosine problem. So the cosine of our angle, whatever our angle is in radians or degrees, but in this case we're talking about radians, that's going to give me the value of x. And for the y value, that's a sine function. So this is the angle measurement. That is theta. So the exact value of P would be the cosine of pi over 3, comma, sine of pi over 3. So in other words, if I stick cosine of pi over 3 in the calculator, it will give me some kind of approximation in radians, but this is actually the exact value for coordinate x. Revisit your answer to 7 after seeing 4, 5, and 6 done. We'll be changing them. Turn the video back on and you're ready to continue. So for problem 7, hopefully you decided to do cosine of 2 pi over 3 and sine of 2 pi over 3. So again, if I gave you, or if I asked you for the exact coordinate for pi, in radians, it would be cosine pi, comma sine pi. So theta is going to be either the angle measurement in degrees, or it's going to be our angle measurement as a radian measure. Problem 8, they're asking you to show mathematically that this point actually is on the unit circle. So in other words, you might be able to look at your unit circle. So the point's right there, so I know it's on the circle. That's what they're asking here. They're asking you to come up with a way to prove that it really is on the circle. And then also, problem 9, they're asking the same question. If I give you this information, can you decide whether or not this point is actually located on the unit circle? Turn the video back on after you and your partner work through these two problems, and we'll continue the discussion. So you may have done this problem differently, but because it is a unit circle, and we are looking for whether this point actually is in the circle, we have been using essentially we've been using right triangles. So one way of doing it, it's not the only way, but it's one way of doing it, is take the square root of 2 over 2 squared plus negative square root of 2 over 2 squared. Does that equal the hypotenuse squared? So the square root of 2 over 2 squared is 0.5. The negative square root of 2 over 2 squared is also 0.5. And 1 squared is 1. So half plus half is 1. So this coordinate is on the circle. So If you didn't get 8 or 9 done, now you've seen problem 8 done, go ahead and put problem 9, turn the video back on, and you're ready to continue. Alright, so in this one here, 0.5 squared plus sine of 4 pi over 3 squared. We actually put the x.2 between sine and 4 goes to pi. And this is equal to 1 squared. So 0.5 squared is 0.25. Sine of 4 pi divided by 3. If I square that, you get to make sure your answer, your number, or calculator is in radians, otherwise you'll probably get a wrong answer. So 0.75 equals 1. So if you get 1 equals 1. So in your calculator, you enter in, again, make sure that the setting's in radians. And so sine, you type in 4 pi over 3, and then the caret key or the x square key, however you want to do that. But this would be kind of the keystroke. These are my calculators to get the answer. So a couple of 2 ways of doing it. Either way, you should get 0.75. I would like to go back to a previous problem, thinking about the answer that I provided. And I made a mistake. It's this one right here. So this one here is cosine of 2 pi over 3. And this is sine of 2 pi over 3. That part's correct. The part that I didn't do is that the y or x value is actually negative. But the y value is positive. So there should be a negative sign in front of the cosine of 2 pi over 3. Because that answer is supposed to be negative. Got the negative sign there. You apologize. Alright, so I got the problem started. So we're looking now at x is cosine, y is sine. So x squared plus y squared equals r squared. So we're looking at Pythagorean theorem. So it's cosine squared theta plus sine squared theta, which is negative 0.5, and a negative 1. So we are told that sine of theta is 0.5. So we are replacing sine of theta with 0.5, and we're squaring. So theta is not negative 0.5. Sine of theta is negative 0.5. And so the problem becomes this. And we're looking for what cosine of theta equals, not what theta equals. So here's kind of the starting point based on the problem information we're given. That's different than problem 12. So in problem 12, they're actually giving you the theta, so you're actually replacing theta with the number. So go ahead and finish off problem 11, and then ask you to find the answer here. It says try these measures for theta, change your mode from, since you're working with degrees and radians, so make sure you check your mode. We are in problem A, it's a degree, but we're in problem B, it's a radian. So turn the video back on and you're ready to talk about problem 11, 12A, and 12B. All right, this is probably going to be the last problem because of the amount of time that the videos are given. So I have a time limit, so 15 minutes. So this is probably the last video. So this is 0.25 equals 1. So let's subtract 0.25 from both sides, cosine square theta. Is equal to 0.75. And then to get cosine theta, we have to take the square root of this. So the square root of 0.75, and this will be the last problem at the time, is 0.866. And we're in the fourth quadrant, which makes x positive. Go ahead and click off to the next video. Again, make sure that when you do so that you have completed as group 12A and 12B.